Chapter 9, Confidence Intervals and Hypothesis Tests on Two Samples. 9.1, Introduction. Up till now, we have executed a confidence interval test and hypothesis test on one population, for which we have tested its parameters, such as mean, variance, and proportion. We had to deal with two major types of situations: large sample and known population variance, z-test; small sample or population variance unknown, t-test. In most serious statistical studies, we need to perform confidence interval tests and hypothesis tests on two different populations, such as a population of men versus women, those who practice sport at least 3 times a week against those who do not practice sport at all, etc. Sometimes we need to perform this statistical study on the same population, before and after it received some kind of treatment, like an adult population who received a new kind of medicine. The overall procedure to execute a confidence interval or hypothesis test of two populations is remarkably similar to the one executed on a single population. However, there are more possibilities, as the two populations may be dependent or independent, the population variances may be known or unknown, assumed equal or different. Therefore, we possess 4 possibilities that shall be covered in this chapter. To compare two population parameters, to investigate whether there is any evidence that they are different, a difference is often used. For example, let's compare the means of two population parameters by evaluating their difference, as shown. mu1 equals mu2 is equivalent to mu1 minus mu2 equals 0. mu1 greater than mu2 is equivalent to mu1 minus mu2 is greater than 0. mu1 less than mu2 is equivalent to mu1 minus mu2 is less than 0. Let's define independent samples. Independent samples are two sets of sample data that are not connected nor related to each other. Example: do people in the countryside are healthier than people living in the city? A sample of 100 middle-aged people was interviewed from a major metropolitan city, and another group of the same sample size was interviewed from the countryside. The two samples are independent of each other. Now, let's define dependent samples. Dependent samples involve the same sample in which the statistical study was performed previously and post-event. Dependent samples are also referred to as paired data. Example: to test a newly developed weight loss treatment, a pharmaceutical company selected 60 volunteers who were tested before and after taking the new treatment. The same sample was tested 2 times, before taking the treatment and after taking it. One last thing before we start doing hypothesis tests: equal versus unequal variance assumption. In most cases, the population variance tends to be unknown. However, sometimes we may assume that the variability around the mean of the two populations is roughly the same, as shown in figure 9.1. Or the variability may be more significant in one population than in the other, as shown in figure 9.2. There are a few approaches used to decide if it is safe to assume equal or unequal variances of the two populations considered. Eyeball test refers to inspecting data in the shape of a box plot or other, and quickly making a guess about the variability of data in the two figures. This is the simplest method. However, it may be subjective. Standard deviations ratio. Take the largest standard deviation, divide it by the smaller one, and compare the result with 2. If the largest standard deviation is larger than double the smallest, then we'll use the non-equal assumption. This is illustrated in figure 9.3. Enough definition. Let's do some serious statistics. 9-2, confidence interval test based on 2 independent samples. In Chapter 8, we conducted a confidence interval test on a single population mean. Since x bar 1 is a good estimator for mu1 and x bar 2 is a good estimator for mu2, it is reasonable for x bar 1 minus x bar 2 to be a good estimator for mu1 minus mu2. To conduct the confidence interval test based on two independent samples, it is necessary to know some properties of the estimator, such as known or unknown variances, or equal or non-equal assumptions, to apply the most appropriate distribution. Let's start with A. Confidence interval to compare two population means when population variances are known, independent samples. The following is a detailed cheat sheet on how to conduct a confidence interval test to compare two population means when population variances are somehow known. This case rarely occurs, but it is a good starting point since it is the simplest to compute and uses the z-table to find the critical value. So here it is, a cheat sheet on how to conduct a confidence interval to compare two population means when population variances are known, with 4 simple steps. Step 1. Get the data, like the sample sizes, the variances, and from the two samples, the confidence level and the significance level alpha. Step 2. Get the critical value from the z-table or from Microsoft's Excel. Step 3. Calculate the error with the formula shown. And finally, step 4, draw a conclusion on the confidence level. What about the significant difference? The confidence interval may or may not include 0. If it does, it implies that the difference between mu1 and mu2 can be 0, which implies that mu1 equals mu2 is a possibility. This means there is no significant difference between the population means mu1 and mu2. However, if the confidence interval does not include the 0, it implies there is a significant difference between the population means. The following table summarizes these scenarios, where LL is the lower limit and UL is the upper limit. LL is less than mu1 minus mu2, which is less than UL. Let's do an example. Example 9.3. Confidence interval on two sample means with known population variances. A study was conducted to compare the hotel rates from two major capitals, London and New York. 60 rooms were randomly selected from London and 55 from NY. The average price per night from London was $410, with a standard deviation of 53.5, and $395 from NY, with a standard deviation of 47.3. Find the 98% confidence interval for the true mean difference between hotel room rates in London and NY. Is there a significant difference between the rates? Let's use the cheat sheet provided in the textbook to solve this problem. Step 1. Gather the needed statistics in a table form, as shown in the slide. Step 2. Find the critical value from the z-table using alpha divided by 2. Step 3. Calculate the margin of error as shown to find E equals 21.86714. Therefore, the confidence interval is between negative 6.8671 and 36.8671. Finally, draw a conclusion. We are 98% confident that the true difference, mu1 minus mu2, is between negative 6.86 and 36.86. Since 0 is part of the confidence interval, we cannot claim that there is a significant difference between hotel rates in London and NY. Let's move to section B. Confidence intervals on two samples. Population variances unknown and equal. Sometimes we may assume that the two populations' variances are unknown but equal by running the test previously described. We use the weighted average of the two sample variances, as shown, and the standard error, as shown in the slide as well. finally, use the t-table with a degree of freedom calculated by the formula shown. Here is a cheat sheet to find the confidence interval on two samples, population variances being unknown and equal. Step 1, get the data from the problem statement. Step 2, find the critical value. Step 3, calculate the error. And step 4, draw a conclusion about the margin of error. Let's do an example on confidence intervals on two samples. Population variances unknown and equal. A researcher wants to investigate if teachers in private schools receive more pay than teachers in public schools. He randomly selects 27 teachers from the public school with an average pay of $38.5 per hour and a variance of 4.22. From a private school, he selects 29 teachers with an average salary of $51.5 per hour and with a variance of 4.46. Construct a 95% confidence interval for the average difference between the salaries of public and private school teachers. Assume equal variances. Let's solve this statistical problem by using our usual cheat sheet. Step 1. Get the data from the problem statement and put them in a table like shown to use them in the next steps. Step 2. Get the critical value from the t-table or from Microsoft's Excel. Step 3. Calculate the error by using the given formula. And step 4, calculate the margin of error and make a concluding statement, like, we are 95% confident that the true difference, mu1 minus mu2, is between negative 14.0803 and negative 11.9197. Since 0 is not a part of the confidence interval, we claim that the teachers from the private schools receive a salary that is significantly higher than the salary received by the teachers in the public schools. Let's move to confidence intervals on two samples, population variances unknown and different. The most frequent case is when the population's variances are unknown and visibly unequal through a box plot. In this case, the standard error will be as shown in the slide, and the degree of freedom is shown in the cheat sheet. Here we go. Conducting confidence intervals on two samples, population variances unknown and different in 4 simple steps. Step 1, get the statistics from the problem statement. Step 2, get the critical value from the t-distribution and using the shown formula for the degree of freedom. Step 3, calculate the error. And finally, step 4, calculate the margin of error and draw a conclusion. Let's do example 9.5 in the textbook. Confidence intervals on two samples, population variances unknown and different. A researcher wants to investigate if teachers in private schools receive more pay than teachers in public schools. He randomly selects 27 teachers from the public school with an average pay of $38.5 per hour and a variance of $4.22. From a private school, he selects 29 teachers with an average salary of $51.5 per hour and with a variance of $4.46. Construct a 95% confidence interval for the average difference between the salaries of public and private school teachers. Do not assume equal variances. Pause the video and use the cheat sheet provided to solve this problem. Let's apply the 4-step procedure provided in the textbook to solve this problem. Step 1, gather the data in a table as shown in the slide. Step 2, calculate the degree of freedom and use it to find the critical value using the t-distribution. Step 3, calculate the error to find 1.1185. Finally, step 4, calculate the margin of error and make a conclusion. We are 95% confident that the true difference, mu1 minus mu2, is between negative 14.1185 and negative 11.8815. Since 0 is not a part of the confidence interval, we claim that the teachers from the private schools receive a salary that is significantly higher than the salary received by the teachers in the public schools. D. Confidence interval to compare two population means, paired data. So far, we have considered that the samples were obtained independently. The N1 observations from the first population and the N2 observations from the second population were unrelated. In some statistical studies, we need to apply a treatment to the same sample and study its effects. This means comparing the pre-test with the post-test properties of the same sample. Sometimes this is referred to as a dependent group or matched group. This slide shows the cheat sheet to use for confidence interval to compare two population means, paired data. Step 1, get the needed statistics from the problem statement, like the pre-treatment sample mean, the post-treatment sample mean, sample size, and difference between pre- and post-treatment for each observation. Calculate the sample difference mean and the sample difference standard deviation. Step 2, critical value from the t-table. Step 3, calculate the error. And finally, step 4, calculate the margin of error and make a conclusion. Let's do example 9.6, confidence interval to compare two population means, paired data. A strength program is proposed by a known professional trainer. To test the efficacy of this program, the 3-minute push-up test is used on 12 volunteers before and 30 days after the application of this strength program. Use the data in the table below to construct a 95% confidence interval for the true mean difference between the pre- and post 3-minute test. Is there a significant difference? Pause the video and try it using the cheat sheet provided in the textbook. Let's use the cheat sheet provided in the textbook to solve statistical problems related to confidence intervals to compare two population means having paired data. Step 1, gather the statistics needed in a tabular format as shown. The first line includes the data pre-treatment, the second line post-treatment, followed by their difference and their difference squared. Calculate the standard difference as shown. Step 2, find the critical value from the t-table. Step 3, calculate the error using the formula shown. Finally, step 4, calculate the margin of error and make a concluding statement. We are 95% confident that the true difference mu1 minus mu2 is between negative 56.7581 and negative 35.4087. Since 0 is not included in the confidence interval, there is a significant improvement in the newly proposed strength program. The following flowchart describes the process to follow to choose the appropriate distribution, normal or t-distribution, to conduct the confidence interval test based on two samples. Pause the video and have a good look at it. Notice that the first thing to know is whether the samples are independent or not. Then, whether the variances are known, equal, or different. For each case, the error is calculated differently. Section 9.3, hypothesis testing based on two independent samples. A, hypothesis testing for two population means, sigma known, independent samples. The procedure for hypothesis testing for two population means is very similar to the hypothesis testing procedure for a single population mean. The following outlines the steps for hypothesis testing. Moreover, the standard error for the hypothesis test is the same for the confidence interval test. Here is the cheat sheet to use for conducting a hypothesis test for two population means, knowing the population's standard deviation, independent samples. Step 1. Make a claim about the population difference, D0. Step 2, define the null hypothesis, H0, and the alternative hypothesis, HA. Determine whether it is a left-tailed, a right-tailed, or a two-tailed test. Step 3, gather the statistics from the problem statement about the two populations. Step 4, calculate the test statistic with the formula shown. Step 5, find the critical value from the z-table and use to reject the null hypothesis, or fail to reject the null hypothesis. You may also use the p-value approach. Lastly, step 6, make a concluding statement.
Let's do an example. Do young people watch less TV than older people? Independent random samples of people in two group ages were surveyed, and the weekly time spent watching TV was recorded for each sample. The following table shows the summary statistics. Is there any evidence that younger people watch less TV than older people? Use a confidence level of C equals 99% and assume that the time spent watching TV is normally distributed. Pause the video and use the cheat sheet provided in the textbook to work this problem. Let's use the cheat sheet provided in the textbook to work this problem. Step 1, carefully read the problem statement and make a claim, like young people watch less TV than older people. Step 2, null hypothesis H0, mu1 greater than or equal to mu2, and the alternative hypothesis HA, mu1 less than mu2. This is therefore a left-tailed test. Step 3, gather the needed statistics from the problem statement as shown. Step 4, calculate the test statistic with the formula shown to find that z equals negative 2.4055. Step 5, from the z-table, the rejection region is z less or equal to negative 2.3263. Therefore, reject H0 since negative 2.4055 is less than negative 2.3263. And finally, step 6, make a general conclusion. There is enough evidence to suggest that the mean weekly time spent watching TV for 15 to 20-year-olds is less than the mean weekly time spent for 25 to 30-year-olds. Let's move to hypothesis test for two sample means. Population variances are unknown and equal. Pause the video for a few moments and have a look at it. Basically, all the steps are similar to the previous case, except for the test statistic that uses the t-distribution and a different formula for the test statistic. Let's do an example about luxury cars. The waiting time to receive a luxury car from a high-end car manufacturing company in China and Mexico factories was recorded in weeks. The resulting summary statistics are shown in the following table. Question 1. Is there any evidence to suggest that there is a difference in the population mean waiting time to receive a newly bought luxury car between Mexico and China? Use alpha equals 0.05, assuming that the underlying distributions were normal and with equal variances. Question 2, find bounds on the p-value associated with this hypothesis test. The solution is very easy and straightforward with the cheat sheet provided in the textbook. Step 1, claim. There is a difference in the population mean waiting time to receive a newly bought luxury car between Mexico and China. Step 2, define the null hypothesis. Mu sub 1 minus mu sub 2 equals 0. And alternative, mu sub 1 minus mu sub 2 does not equal 0. Therefore, this is a two-tailed test. Step 3, gather the data. Number of observations, sample size N1 equals 15, and sample size N2 equals 17. Sample means x bar 1 equals 17.4, and x bar 2 equals 12.1. Population common variance, the pooled estimator, is calculated from the formula shown. Step 4, calculate the test statistic by the formula shown. Step 5, find the critical value from the t-table. And step 6, make a general conclusion.
there is no evidence to suggest the mean waiting time to receive a new luxury car from the China factory is similar to the Mexico factory. What about the hypothesis test on two-sample population variances unknown and different? Here is the cheat sheet to use for this case. Here again, we shall use the t-distribution with a different formula for the test statistic and the critical value for steps 4 and 5.
The following is the cheat sheet for the hypothesis test to compare two population means paired data. Here is the cheat sheet to use for this case. Notice that it is convenient to gather the data in a table format showing the pre- and post-treatment data in step 3. Here again, we shall use the t-distribution with a different formula for the test statistic for step 4.
Let's do example 9.10 in the textbook to illustrate hypothesis test to compare two population means, paired data. The height of tropical roses was measured in centimeters before and after some newly developed treatments. The data is given in the following table. Is there any evidence to suggest that the new treatment reduced the mean height of the roses? Assume that the underlying distribution of initial and final height is normal and use alpha equals 0.05. Pause the video and use the cheat sheet to solve this problem. Let's solve it. Step 1. Make a claim. The new treatment has reduced the mean height of the roses. Step 2. Define the null hypothesis H sub 0, stating mu1 minus mu2 is less than or equal to 0, and the alternative hypothesis H sub A, stating that mu1 minus mu2 is greater than 0. Therefore, this is a right tail test. Step 3. Gather the data. Sample size n equals 12. Degree of freedom df equals n minus 1 equals 11. Calculate the sample mean of the differences. Step 4. Calculate the test statistic to find 2.5125. Step 5. Find the critical value of 1.7959. Reject the null hypothesis because the test statistic t equals 2.5125 lies in the rejection region. Step 6. Make a conclusion. There is no evidence to suggest that the treatment does reduce the tropical rose's height. The following slide shows a flowchart to use when deciding which hypothesis test on two sample means should I use. Notice the first question concerns whether the samples are independent or not. Also, notice that the t-distribution is often used. Pause the video and have a good look at it. Section 9.4. Comparing two population proportions. In some statistical studies, we may need to compare two population proportions. Let's develop a method and identify the appropriate distribution for this purpose. Let's start by recalling the notation describing the population parameters and the sample statistics for two different populations, shown in this table. The following cheat sheet shows how to easily conduct the confidence interval to compare two population proportions. Step 1. Gather the needed statistics from the problem statement. Step 2. Find the critical value from the z-table. Step 3. Calculate the error by using the shown equation. And finally, make a concluding statement about the confidence interval. Let's do problem 9.11 in the textbook. It is believed that by 2022, more people use the internet in European countries than in South American states. To test this claim, a random sample of households in France and Mexico was taken. The following table shows the statistics obtained. Is there any evidence to propose that the proportion of households connected to the internet is greater in France than in Mexico? Use alpha equals 0.01. Pause the video and use the cheat sheet provided in the textbook to solve this problem. The solution is straightforward with the cheat sheets. Step 1. Gather the needed data from the problem statement. Step 2. Find the critical value, either by the normal distribution or Microsoft Excel, as shown. Step 3, calculate the error, as shown, and find the confidence interval. Finally, make a concluding statement. Since 0 is included in this interval, there is evidence to suggest that the two proportions are not different. Let's conclude Chapter 9 in the textbook with the following cheat sheet about how to conduct hypothesis test about two population proportions. Step 1, make a claim. Step 2, define the null and the alternative hypotheses, and also the test type. Step 3, get the needed statistics from the problem statement. You may want to check the non-skewness criterion to be able to assume the normal distribution. Step 4, calculate the test statistic with the shown formula. Step 5, find the critical value by using the z-table or Microsoft's Excel. And finally, Step 6, make a concluding statement.
For more lessons on descriptive and inferential statistics, check out our textbook, Illustrated Statistics for College Students, available on Amazon. Thanks for watching.